All right, let's take another look at a piecewise function and the application of limits to that. Mentioned this in the previous video. In my opinion, the best way to graph a piecewise function is to create a table of values and then use what we know about the form of this function to sort of make it look right, for lack of a better word. This is a linear function. This is a quadratic function. So we know this first piece is a straight line. This second piece is a parabola. What part of the parabola, I don't know yet. Okay, when it comes to plotting points, first and foremost, we are always going to use this point. Even though 1 is not in the domain of this function, I am going to put the number 1 into this function. Okay, and I'm going to get an output of 3. Now, here's the thing. Because 1 is not included, I know that this is a hole in the graph. Okay, so I have to have that placeholder there and why is that? Because 1 might not be in the domain, but 0.999999995 is in the domain, right? And if I put 0.999999995 into this function, okay, I'm going to get a point that is so incredibly microscopically close to 3 that I might as well just put a hole there. Okay, now after that, we can pick any numbers that we want that are less than 1. So we can plug in -1. If we plug in -1, we get an output of 7. If we plug in -2, we get an output of 9. Okay, and that's probably enough to start graphing that piece to the function. Okay, now while I'm here and while my face is covering the graph, why don't we go to this next piece? And again, we're going to start by plugging in the number 1. We're going to put a 1 here. 1 squared minus 7 is -6. Now let's put in a 3. If I plug a 3 in, 3 squared is 9 minus 7 is 2. And it's going to get pretty crazy fast here. So if we plug in 4, we would get an output of 9. Okay, so if I move myself down here, this first part, I'm going to go to 1, 3, and I'm going to put a hole in the graph. Then I'm going to go to -1, 7, and I'm going to put a point. Then I'm going to go to -2, 9, and I'm going to get a point. Okay, and then I'm going to connect all of these points for all of the values of x that are less than 1, right? All the way up to where that hole in the graph is. Then I come down here and I plot the point 1. So I'm now going to the second piece, which is at 1, -6. Now that is a point. That is not a hole. Why? Because we are including 1 in this domain. So I'm not making that a hole, I'm making that a point. Then we go over 3 and up 2, over 4 and up 9. And I don't have a parabola graphing tool here. Okay, so I'll do my best to connect these, but you see that this is going to be 1/2 of a parabola there, right? Okay, so for the, 12th time, the limit as x approaches 1 of this function. Okay, well, let's talk about it. Let's talk about the two-sided limits here. As we approach 1 from the left, this is us approaching 1 from the left side of this function, the output of that would be -3. As we approach 1 from the right side of this function, that would be -6. So because we're not seeing that ET moment happening, okay, we're not seeing that convergence, we're seeing something coming in like this and then something going up past it. We're not going to see that convergence. So we know that this limit does not exist. And then let's talk about the value of the function at 1. Okay, you can't say, well, which one of these do I pick? This is a hole in the graph. This doesn't exist. That is an open space when x is 1, right? The only point that exists when x equals 1 is this point down here, which is a value of -6. Okay, so again, a limit cannot exist, but the function can have a value, right? And vice versa. We'll see a couple examples of those later on.